Welcome to a lesson with Dr. Powell. Let's take a look at why the direct sum of two objects in an abelian category is isomorphic to the direct product of two objects in that same category. Well, how are we going to do this? We're going to show that the direct sum satisfies the same universal property as the direct product. That will imply that they're isomorphic if they satisfy the same universal property. So we start off looking at the universal property for the direct sum. Say we have two maps I1, I2 coming into A plus B. You can call this the cocone of just a simple diagram of A, B. Okay, and in particular, if we have any object A such that we have maps coming up to it, I mean, it could be anything, but I'm just choosing A as one of the objects, and let that be the zero map, there should be unique, or there exists a unique morphism that goes from A plus B to A that'll make this whole diagram commute. I'm going to call it P1. Notice immediately we get some results. P1 composed with I1 like this is actually going to be the identity map. And we know that P1 composed with I2 is going to be the zero map. Ha! Well, P1 goes back down to A in the following way. So A, and we have I1 coming up, P1 coming back. Let's see, that's A plus B, back to A. And likewise, we could define a map P2 that does the same type of thing by analogy on the other side. P2 coming back down to B. And such that this right here, if we run I1 then P1, we should have the identity right there. Similarly, we should have the identity right here. And I mean, just kind of looking at these for a minute, if we have I1, and let's suppose we put any map before it like that, and we run, and let's suppose that this composition is actually the zero map. Then if we composed P1 on both sides of this, notice what we'd get. On this side we'd have a zero map. This side, this is the identity, we just get alpha is equal to 0. That actually means, so if this equaling 0 implies that map 0, that's the same thing as saying that I1 is a monic. So you have I1 is a monic, I2 is a monic, but you also have these P1 and P2 with a similar argument. You can actually show that those are epis. So we have an epi, a monic, this is identity, kind of a nice set of maps, and that just came directly from the universal property of the direct sum itself. But this looks a lot like what you'd see already for a direct product. If you just looked at P1 and P2, you get a mapping cone coming down, P1, P2 coming down to AB. So this is already looking pretty promising. All right, let's suppose that we have just any object, C, and we're going to think about C1 as having a map to A, call it G1, and a map to B, call it G2. And we think, all right, first of all, does there exist a unique map from C coming down to A plus B such that this will commute with the diagram with P1 and P2 in such a way that's the universal property of the direct product, and then that would show that A plus B will be isomorphic to the direct product. And then we're done. So let's think about how that would go. Well, first of all, we do have, because of this I1 and I2 coming up, and since we're in a abelian category, we can add morphisms. We actually have a morphism that comes, let's see, we actually have a morphism that comes down this way, and this morphism, well, let's call it H, and we can specify what H is. It's going to be I1G1 plus I2G2. So we already know we have a map that comes, so this H, think about it, G1, I2 comes up, and let's see, G2, I2 comes up to here. And if you add those, you do have a map from here to here. Now, notice that this map actually will actually makes both sides commute. How so? Well, let's see. If you take H and then you run P1, what happens? Let's just think for a minute. We have P1H is going to be P1 I1. Well, let's just distribute it across because we can do that in this category. We have P1 I1 G1 plus P1 I2 G2. Notice this guy's just 0, and this guy's just G1. Ha! It does commute. So H is a nice map that actually makes this diagram commute. If we just show it's the only one that works, we'd be done, so that it would be unique. Now to do that, we're going to look at the following. We're going to think about the following map here. A, B, and we're going to use the universal property of the direct sum again. A plus B. This time we're going to go up to A plus B. Okay, and we're going to go I1, or I2 that is, and then here I1, I2. Well, obviously, the unique map that makes this commute is the identity map. But there's another one that works, which is actually going to be equal to the identity map because it has to be the same. It's unique, right? So if we chose to use simply I1 P1 plus I2 P2, okay, so thinking about, so this map right here actually will go to, so thinking about what I1 P1, let's see, yes, we want to get this right here. Notice, well, we have to maybe just rewrite that. Okay, so we need a map that comes from here to here. So it looks like, yeah, well, if we did I1 P1, sorry, so like I1 P1 like that, so we first do P1, then come up I1, and then we add to that I2 P2, so right, so that map comes from here to there, and then from here to here, and then we're going to add them. So that will be a map from A plus B to A plus B. And this map actually makes this diagram commute. How so? Let's think. Well, if we precompose it with I2, what happens? If we precompose it with I2, so we have an I2, this part will, so P1 I2, let's think about that. Let's see, P1 I2 is just 0, right? So this one is just 0. And thinking I see I2 P2, so go, let's see, well, it's just like, or P2 I2, right? Because P1 I1 is the identity. So yeah, so P2 I2 would be the identity map. And what do we end up getting? We end up getting I2 itself. Oh, wow. Which makes this side commute. And similarly, it will commute on the other side. So by uniqueness, we actually have another way of writing down the identity. The identity map is simply, let's see, yeah, it's simply I1 P1 plus I2 P2. this is equal to the identity map. And so using this, we can actually show that this H map is unique. All right. And so how are we going to do that? Well, let's just suppose that T is another map that works. All right. So what we're going to do with T, if we compose it like by this identity map afterwards. So if we say the identity map of T, that should be T, right? It's the same thing. But if we run it, we're going to have I1 P1 T plus I2 P2 T. And notice when we do this, if we group it like this, okay, knowing what, so T is a map that makes this commute, so that means that P1T is just G1. So this is really I1 G1, and similarly this is plus I2 G2. Wait a minute, that's the same thing as H. So really T is equal to H, which means H is unique. We are done. We just have shown that the direct product satisfies the universal property of, that the direct sum of A and B satisfies the universal property of the direct product between A and B. Thanks for watching.